That was a meme, wasn't it? The chill guy meme. I'm just a chill guy. That was a great meme. I really liked that one. Yeah, he was just such a chill guy. Didn't last very long though, right? If we think about like the chill guy meme. Oh, you got Master Chief coming up. What's up, Gavin? All right. Come on. So yeah, there's that question. That's the live upload counter. That's that. Where's my admin panel? There's my admin panel. Where's my go live? What's up, dude? Gavin, did you submit this question? Is this your question? My day's doing great.
Good job.
It's a nice Sunday. I just want my chat to work, please. Thank you. There we go. Okay. All right, now we got that. Now I just need TikTok chat to work. Hello? Let me just test it here. Oh, it is working. Okay, cool. All right. Use the following circuit. So this is cool because I literally was just teaching circuits the other day and I was doing state tables. So for instance, this isn't related to your question, but it's in a similar subject. Here I was showing how to add two variables in a sequential circuit in binary. And you have to create like state tables. And then from that you can build like what's called like an FSM diagram, which kind of shows what the input is and then what the output is and how the states change. It's really cool. I'm really enjoying. It's funny. I'm tutoring this class to somebody, but I've never taken it before. But I've worked with this student in other classes, and they just know I can learn things quicker than they can, and then I can explain it to them. So I'm getting paid to basically learn a logic class. It's really fun, actually. I'm really enjoying it. Okay, so this looks like a huge clusterfuck, though, by the way. Sorry, what? I see ISAB. And then these are negators, right? I wish there were more chemistry questions. They'll come up, Kato. They do. They don't worry. The chemistry questions, they appear. Maybe if I started making, I have a decent amount of chemistry TikToks, but maybe if I made even more, that would like put the algorithm towards even more chemistry stuff. Also, I have started to notice that TikTok is monitoring my audio. They transcribe what I say here and they put it into text. So if I keep saying chemistry, this algorithm will start showing it to more chemistry people. And I think we've had trends there, right, Kato, where if I'm working on a chemistry question, like another chemistry question gets submitted. It's very fascinating. I mean, TikTok has for them to on the fly adjust the audiences is really crazy. Makes sense though. Okay, but looking at this question, I'm a little bit confused what all the dots mean. Like what is all this? What are these dots like? What is a solid dot here? This usually means a juncture, right? Does a line mean it doesn't connect? Shame that they got bought. Did the US force them to sell them to like Oracle or something? So if we look at, for instance, and then I don't know exactly what the clock does here. Clock is usually like to advance it. Like if this was a sequential circuit, it means that it waits for the next bit, right? I think the US forced them to sell to Oracle, by the way, though. And then this is D, and this is Q, and then this is not Q. Sorry, but what's Q and not Q? There's a couple things. Like, what the fuck is Q? And then okay, I get it. Q is what is getting written, but then what is this thing? What physics do you teach? I mean, at UCLA, I've taught like mechanics and E&M for like undergrads, but I teach everything. Anything I say middle school up through college or something. Average us being racist, to be honest, the whole thing in the Senate. Yeah. Dude, that was funny. It's like, so you are China. And he's like, no, I'm from Singapore, sir. But to be fair, TikTok is probably kind of influenced by governments, I would say, for sure. Hardest physics unit in university, do you think? For me, quantum. Quantum's the hardest. Here's the other thing. So I and S are standard inputs, while A and B are data inputs. What does that even mean? Because Because I see a bunch of zeros and ones here, right? Man, I want to understand this, because this is a cool looking question. Because I feel like it's close to what I already do with logic, but there's probably a little bit more nuance to it that I don't understand. So I'm going to ask chat to analyze it for me. Because I want to learn this. I want to learn what the hell this is. This looks fun. Gucci Goody. Oh, we also hit 2,100 followers. Nice. Kato, I think you were the 2,100th person, by the way. Thank you. 2 hours ago. What up, Gucci? Do you know about circuits? I mean, I know about circuits. Sorry, do you know about this type of circuit? I know how to do state tables. I'm confused what this thing does. This is digital logic design. Okay, thank you. All right, so thank you, TikTok. Someone on TikTok recognizes what it is. I know logic. I know how to design logic gates. The water in A gets there first. How do you see that from here, by the way? Sorry, what? From what I see, like, these are junctures. Oh, D is a flip-flop. Okay. So, sorry, so this is like a memory unit? I mean, usually I think about it like this, right? This is like a memory unit. That's initialized to 0, right? So, during one clock cycle, that pops out a 0. And then let's say you put a 1 as an input, and then that gets stored as a 1. And then the 1 gets popped out, and then let's say you put a 0, then the 0 comes in. JK, you don't water there. Any quantum mechanics questions? Not yet. Not yet. We have a digital logic design question coming up right now. Okay, so if we assume this is a flip-flop. Okay. I think I can kind of understand that. And then these are the possible inputs for ISAB. I understand these are the different inputs for ISAB. And we want to say what Q is. I'm just confused how to read this with the dots. Because, like, why are these connected or no, right? Things are only connected when there's a solid dot between them. This is kind of a, like, dude, this is like messy circuit design. Like, what? So what? I mean, this is like a path I see, right? But then this is also a path. Gucci has a question. What would segue between algebra 2 and linear algebra? Ooh. That's a good. Do you need calculus for linear algebra? I don't think you do. It helps though, right? If you understand like cross products and stuff, those help for linear algebra for sure. So maybe calculus. I would say like multivariable calculus almost would maybe help. Just like getting a handle on like what cross products are. The general progression, at least in the United States, after Algebra 2, is usually that you take pre-calc, and then you take calculus, and then from there you can... So calculus then goes into vector calculus, which is multivariable calculus, and then from there you can either go Diffie-Q or linear algebra. I think both are valid. I don't think cross products are algebra. No, I don't... They are linear algebra, but they're not regular algebra for sure. The American codes for topics. Yeah, because like trig is like pre-calc as well. What does Kuhn Tucker go under? Am I getting baited into a fucking joke? God damn it. Okay, I think this goes here. Right? And then it can do this. I wish I understood how to read this. All right. Okay, let's see. Let's see what ChatGPT's still answering. Dude. I'm gonna tell it to answer. Fuck now, dude. You're in trig right now and it's confusing. Well, if trig is confusing for you, please submit a question to our live stream. So there's this website here. It's called www.actualofficehours.com, and there you can like put in a username that you want me to recognize you by, and then you can drop a screenshot of your question and I'll go through it and just hit upload. I can't even do trig and I'm a filthy chem student. Well, I hope you can do at least like sine and cosine stuff. Okay, trying to do the diagram, but before I need one clarification because it's a PLA style ROM driving a D flip-flop. So I understand the flip-flop, I think, is memory. So the only way to determine next state logic is to know... Oh, man. Determine Q star and the Z outputs. What the fuck is Q star? Is Q star like not Q? Div and curl or calculus? Okay, then yeah, I would say you need calculus for linear algebra then. See, now you've just made me consider calculating the hypotenuse of chemical bonds for the first times ever, and I hate it. Oh no. Okay. Whoever submitted this is not really giving me much help, so I don't know really how to do this one. But I am gonna at least add it to our Discord. So maybe if there is someone who knows digital logic design, I can help with it. I've never done digital logic design. I've done logic, and definitely logic design. But Jacob, if you want to go join our Discord, maybe someone who knows digital logic design will help you answer it. If not, ChatGPT will take a look at it. They'll try. But it looks like chat already has like questions for it. Which is okay. I would say like submit it and let me see if I can do it. If I can't, I'll try to learn it to do it. In this case, I can't really learn it because I'm not going to learn digital logic design. Digital logic, my goat. See, there you go, airbag. See, bro, I'm telling you, dude, the TikTok algorithm is listening to everything I say. I said digital logic, and just like saying Biggie Smalls 3 times, some person pops up in my TikTok saying like, hey, digital logic. Yeah. Whoever submitted that, I'm also taking digital logic right now. Okay, cool. So here's my question for y'all. Because I've never taught digital logic. I've taught logic, and I've taught some like circuit design logic stuff. If y'all want to go like join my Discord, which again, the website actualofficehours.com, go to join our Discord. That question will be posted in the homework help forum, and I would love to see you guys answer it or like discuss it. Try discrete math. We've definitely done discrete. Okay. Next question comes from H. This is the blurriest screenshot I've ever seen. Yes, Maria. Yeah, inclines. I can help you out with inclines. Submit me a question, Maria. Dude, the queue is so low. There's only one question in the queue right now. Please submit me a question on inclines. Are we allowed to do self-promo in chat? Yeah, I mean, you can say whatever, I guess. Just, be chill about it. Don't, All right. The star Antares has a surface temperature of 3660 K. Astrophysics, right? And it's 600 and is 680. I can't fucking read that, but I'm gonna say 680 times the diameter of our sun. Assume that it radiates like an ideal spherical black body. Calculate the peak intensity wavelength of the spectral emit. If this is Stefan Boltzmann, yeah. The goal is not to submit the worst screenshot. Seriously, Jesus. Okay. Black body radiation. That goes as a function of temperature, no, right? What's the equation for that? What's up, Maria? I see you in my chat. Or see you in my Discord. Is it just t to the 4th? I think it's a little bit more complicated than that. Bro took a pic of the test. Yeah, maybe he's on. Well, it's Sunday. There's no way he's taking the test right now. It is proportional to t to the 4th. Peak intensity though. I want peak intensity. Okay, thanks, Maria. We're gonna do that next. Yep, I'll do it next. I will do that next. Okay. Wien's law? Where's Wien's law? That's a cool one. Yes, I think you are right there, Skull Army. I think it's a thing called Wien's law. There we go. Yeah, cool. Nice. Yeah, where it comes from, it probably has to do something with HF. But what it says is, right, lambda peak T is equal to 2.89, or 2.9 times 10 to the minus 3 meters Kelvin. So that means that lambda peak is equal to 2.9 times 10 to the minus 3 divided by the temperature. And notice this is K, which means my temperature needs to be in Kelvin, which I said it was 3660, right? So 3660. Cool. So then we can just calculate that. That's not too bad. Where's my calculator? Okay. Is it Wien's law? What's this dude's name? Wien? I like Wien. Wien sounds fun. Okay, divided by 3660. And then usually we want this in nanometers. So this is 7.9 times 10 to the minus 7. But meters kind of sucks. So just divide that by 1 e to the minus 9. Because that's a wavelength we know about. Nanometers is like the visible spectrum. Cool, 792. So I think that's almost barely visible, right? 792 nanometers. Wiens. Oh, the W is like a Wien. Wien. Oh, it is Wien. Okay, find the ratio of the total power radiated by Antares to the total power radiated by our sun. Interesting. So that okay. Total power is going to be like intensity times surface area, right? I would imagine that, right? Right? Total power. It is, well, it's proportional to the surface area, I think. Right? Because usually, intensity, for instance, is equal to power divided by area, right? And I think there's an equation for this. Right? So total power is equal to area times intensity. And then I think, and then this area, this is 4 pi r squared, right? Because that's the surface area of a sphere. There's some equation. Someone said it actually, sorry. Was intensity goes as t to the 4th? Is that what it was? This is astrophysics technically, but there is some definitely some chemistry aspects to it. Yeah, sorry, where was it? Sorry, Blackberry. Radiation intensity. Where's the equation? I think it is just t to the 4th. There we go. This is what it is, right? Energy per square meter, E. Yeah. Yeah, okay, I think it's Stefan Boltzmann. Yep. I can try. I can try to help with... There we go, this is what I want. I will warn you that some of the engineering materials stuff is just like brutal. And I just don't know all the jargon. But I do have engineering people in my chat who will maybe take a stab at it. Okay. So we assume this is the same, right? For every whatever radiation thing. And Maria, don't worry. I'm done here in like 3 minutes, and then I'll do yours. So, okay. So power sun. And what do they want the ratio? What? The ratio Antares to the sun. Okay, so your ego's thriving. I'm glad, Samsung. You're in 8th grade, dude, learning about that. That's cool, dude. Power sun. So this is going to be sigma A Antares t to the 4th. And what was t for Antares? 3660. 3660 to the 4th. And then this is sigma A of the sun. And then this was... It do be like that sometimes. 5900 to the 4th. Right? But then this cancels. So I don't need that. And then area... Okay, so area is equal to 4 pi r squared. So I can replace this with 4 pi RA, which I think we want things in terms of the diameter, I think, maybe, right? So this is the same thing as 4 pi d over 2 squared, which d over 2 squared becomes d squared over 4, so it just becomes pi d squared, right? Cool. So I can now replace this with pi dA squared 3660 all to the 4th over pi d sun squared. Really, they just say cosine? No, you can't just divide by cosine. It doesn't work. Where did I get this question? People submit it. If you want to submit a question to our live stream, website's there, actualofficehours.com. I'll go through them. I'm going to do Maria's next, because she has a physics test coming up. But anything else, I will then start going through the queue in the order it's submitted. This goes away, this goes away. And then what do they tell us? Oh, so the diameter of Antares is 680 times the diameter of our sun. Sick. So now I can rewrite this as 680 ds squared. So that's going to cancel too. So now we have 680 squared times 3660 to the 4th over 5900 to the 4th. Exactly. Yeah, very neat, right? All right, let's see what the question is. Or sorry, let's see what the answer is. I want to get a number here. You're not going to use this shit in the real world? If you're in astrophysics, you will, dog. Dude, what? I mean, if your job is like putting the fries in the bag all day, like, no offense to McDonald's people, like, yeah, you're never gonna fucking use this. But if you want to go be an astrophysicist, you're 100% gonna use this. Yeah, well, that's why we just leave it to the calculator. The calculator will take care of it, right? Sometimes it won't. You will. Sometimes we will get an overflow, but I don't think we will this time. Yeah, there we go. Cool. So 68,000 times. So we're here. 68. 475. So there you go. So the power of Antares is equal to 68,000 times the power of our sun. Nice. Cool. Good question. Yes, Kato, I 100% agree with that. Kato, you are so right. That's what I always tell people. Yeah, I mean, trust me. Am I ever going to use this shit? No. But the fact that I had to, like, see a problem I didn't know how to do, figure out what equation to use, apply said equation, do some math, get answer, that's a lifelong skill in life. A lifelong life skill to be able to apply to any other problem. You have an asterisk, and, dude, yeah, look, some people have an exam on this shit, like, coming up. So maybe they do need help with it. Anyways, good question, H. Odin root, funny snake. Let's mark that as done. And then I'm going to drop the screenshot for it there. Yes. Leckel's used quantum mechanics a few times because Leckel's PhD's in quantum mechanics. Okay. Let's see. Number 6. What do we got for number 6 here? Oh, this is cool. Do you want to come on the stage, Maria? You got a mic? Do you want to talk? Sure. Cool. All right. What up, Maria?
What up?
How is... You know, I haven't seen you for a bit, so I assumed you were doing well in physics. You're like, that's good.
Yeah, it's been mid.
It's been pretty mid?
But, yeah.
Oh, dear. Okay. Okay, let's see. This looks like vectors is what this is, yeah?
Yeah.
All right, let's like maybe draw this out. I think drawing this out usually like kind of helps first. So 30 meters east. So if I put like a little red arrow or something, right? There you go. That's 30 meters east. Then 180 meters south. Okay, so we're gonna go. This is not to scale at all. 180 south. And then 75 meters, 30 degrees northwest. I never know how this is measured. Like, so is it 30 degrees north of west, or is it 30 degrees west of north?
I don't know.
I don't know, right? Yeah, what is it? Yeah, because like this is technically northwest, right? But I don't know if this is 30 degrees or if this is 30 degrees.
I think it's the first one. Or is
You think it's the first one? Yeah, Jeff thinks it's the second one. Oh man, let me double check. Sorry.
Wait, she has an answer key, I think.
Oh, she has an answer key. Oh, can you see real quick like which way she does it?
Yeah.
It's a weird thing. I hate this. They'll do like north 30 degrees east or something, and this means 30 degrees east of north. It's fucking backwards. I hate it.
See me, I just kind of guess on the test and hope it's right.
I know. I mean, that sometimes works.
And number 6. She doesn't have a triangle, and it's like the.
She just has a triangle.
It has like a. Wait, maybe I can take a picture and send it to the chat.
Yeah, take a picture, send it to the chat. Let me see it. What are ECF mark? Kato, what's an ECF mark, dog? What? Like partial credit? Is that what ECF stands for? Does current flow between 2 points with the same potential? No, usually doesn't. Okay, cool. There we go. Nice. Okay. Yeah, she measures it from the x-axis. Okay. Good to know. All right, I got it. Okay, so this is what she's calling 30 degrees. Oh, yeah. Error carried forward. Okay, that's cool. Yeah, so I agree with putting everything into vector form first. That's a great way to do it. I like drawing the picture first. I think pictures are fucking cool. So what happens is you have like a new coordinate system here once you get to here. And then that gives you a new distance that's going this way. And then this is 30 degrees. And that's a length of 75. Okay, cool. So now we know northwest means north, so like above, right? North is above of west. That's what northwest means. Okay. Distance traveled. Right, so distance doesn't care about direction. Displacement does. Do you know the difference between displacement and distance?
Isn't like distance like the whole thing traveled, and displacement is the starting and finishing?
Good.
Point?
So in this situation, let's say I went 8 forward and 3 back. What's the distance? What's the displacement?
Distance is 11 and
Good.
Displacement is 5.
Nice. Yeah, very good.
Yeah,
Cool.
a little something.
Yeah, you know your shit. Yeah. So in this case, right, I mean, this is a little bit more complicated because we're moving in, like, not just left, right. We're also going up, down. But it's the same stuff. Distance doesn't really care about the direction. So that's just going to be 30 plus 180 plus 75. So that ends up being, what's that, 210, 285? Yeah, this is 285, I think. Okay. What was my thesis on? It's on the website there, Leckel. If you click on my bio, my thesis link is there if you want to go watch it. So displacement, this is trickier, right? I like how your teacher does it. They break these up into vectors. Have you dealt with vectors before?
Yeah.
Yeah, okay. So, how would I write this thing as a vector? So it's like something comma something.
Like 30 comma 0?
Good. Yep. Because you're going positive 30 in the x direction, you're going 0 in y. So then what would this one be?
0 comma negative 180?
Yep. Nice.
Yeah, if you're going south.
Perfect. Okay. This is where things get a little tricky, right? What are we going to do on this one? Uh-oh.
Tutoring?
It is definitely 30. Yeah, there's something with 30. But then we have to use a little bit of trig here, right? So this always makes like a right triangle.
Mm-hmm.
And this right here, right, that's the x component that we're looking for. Which, if you use trig, right, and this is a right triangle, this right here is the hypotenuse. And what is this side?
The adjacent side.
Good. And so I think what trig function has adjacent and hypotenuse in it? And that's cosine, because that's the... Good, yep. So cosine of 30 degrees is going to equal my adjacent side, which I'll call like x, and then over the hypotenuse, which is 75. So then you just take this and you move it over the other side, and you get 75 cosine 30. So we're going to rewrite this as 75 cosine of 30 degrees. And then I made a slight mistake here. Do you know what I did wrong? It's always good to see like what mistakes I made. It has to do with the direction. Good. It is negative. Very good. Yep. This is negative 75 cosine of 30.
Why is it negative though?
Because we're going to the left. We're going to the left.
Yeah.
Right? If we're going to the left, then it's negative.
Yeah. Good.
Okay, cool. So then, what's the y direction one going to be?
Isn't it the same thing without the negative in it, and it's sine?
Yes, and it's gonna be sine. So if one of these is cosine, the other one is always sine. They're always, and the reason why that is because they're technically like orthogonal. But yeah, you can always just know that. Okay, if one of these is cosine, the other one's sine. Yeah. Nice. Okay. Okay. So this is going to be 75 sine of 30 degrees. Good. And then this one's positive because we're going up. What does orthogonal mean? Orthogonal means 90 degrees. So notice how like X movement user and Y movement are 90 degrees to each other. That's also called being orthogonal. What you learn later is that like sine and cosine are orthogonal to each other. They're like perpendicular in a way. Yep. Okay, cool. All right, so then the next thing to do is to get like actual numbers for these, which this is where it kind of helps if you remember pre-calc, because the sine of 30 degrees is something very easy. Have you memorized your not unicircle, but like how to do these ones like sine, cosine of like 30, 60, 90?
We did memorize it, but I do not remember it whatsoever. It's
okay. I have a video on this actually on like kind of the easy ways to remember it. There's only like 2 triangles you have to worry about. I'll show you real quick what they are. So it's this one, which is 1/2 square root of 3 over 2 and 1, where this is 60 degrees, and this is 30 degrees, and this is 90. Okay.
And the other one is 45, 45, 90. Good.
Yeah, the other one's 45, 45, 90. And once you know those, you can figure out everything. It's pretty chill. So I need to like draw the correct triangle though. There we go. And then this one I remember is like 1, and this is like square root of 2 over 2. Square root of 2 over 2. So if you just like picture these triangles in your head, and I say, okay, sine of 30. Okay, where's my angle 30? 30's here. And then sine is opposite over hypotenuse, which is 1/2 over 1. Oh, thanks for the heart puff. Be the human person with humanity. I hope we do have humanity here. So this is 75 times 1/2. Do you see how sine of 30 there was 1/2?
Yeah.
Okay, cool. Then what would cosine of 30 be?
Wouldn't it be the same thing, just negative?
Close. So cosine, right, is the adjacent over the hypotenuse, right? So looking at this triangle, what side's the adjacent?
To the 30?
Adjacent to the 30 is which side? Or which number, I guess?
1.
This is the hypotenuse. The diagonal is always the hypotenuse.
The radical 3/2.
This is good. Exactly. This is the square root of... This is the adjacent. Yes, Sakatoa. Sokatoa. Not Sakatoa, dude. What? No. Damn it. It's not Suckato, dude. What? That's the wrong website. This is the adjacent over hypotenuse. So this is negative 75, and then you just say square root of 3/2. Cool? All right. So then the last thing to do to like figure out what we call like the resultant, right, is to add up what all the different x and y components are from all these matrices. Okay. So that's what your teacher does. It says x, y. And so here you have 30 and 0. Here you have 0, negative 180. And then you have negative 75 square root of 3/2, which I don't know. I need a calculator for that. Square root of 3/2 is like 0.7 or something. This is giving me flashbacks to high school. Yeah. Kato, I thought you said you didn't know how to do trig. Now you do, dude. Yeah, see, square root of 3/2. Oh, I was right. It was 0.86. Okay. Okay. And then times negative 75. So you get negative 64.95. And then this one is just going to be 37.5. This is physics, but it's also kind of math. Vector addition is definitely a math concept. Yeah, for sure. Okay. So, and then you're going to get like what the total is. Okay. So here's like the total. So we're going to add these together. That's going to get me negative 35.05, I think. Or no. Can I do math today? Oh, negative 34.95. I don't know what I'm doing. Yeah, okay, cool. Negative 34.95. Right. And then this is going to give you negative 152.5. I think. Fast math today. Or negative 142.5. There we go. Yeah. Hey, man, can I DM you something? I feel it would benefit me a lot and you'd be interested in it. Yeah, sure. What is it, Charlie? You can send my DMs whatever. Like, it's cool. But I'm curious now. All right, so this is what's called my resultant vector, Maria, by the way, okay? So my resultant vector, which is like the total overall displacement I move, is I'm going to move negative 34 to the left and 142 up. Or sorry, this is negative. My bad. So it's like this. So this is negative 34.95, and then this is going down negative 142.5. So if they want to know the displacement, and I know these two components, how do I figure out what the displacement is?
Isn't it like distance divided by...
So that's going to be speed and stuff. So...
I know this.
You're getting it's close. Okay, so we did distance first, right? Distance was adding all just the numbers up. Displacement is like the distance from your starting to your finishing point. So looking here, this is obviously not to scale. I should have drawn this a little bit better, but whatever. This should do something like this. That's how we do that. There we go. That's what it should be. This is my starting point, Maria, right? This is my start.
Yeah.
And then we figured out where our finish is, right? This is my finish. And then this vector right here, that's what this vector is. That's what happens when we add up all the individual vectors. We get what the overall, it's called the resultant vector is. It's like, what's the overall result of going to the left, going down, and going up diagonally? It's like, oh, well, it's the same as going down diagonally to the left. And then this distance here is the displacement. Does that make sense?
Sort of.
Sort of. Okay. Let's think about it in like two. Let's think about it in like 2 dimensions. Okay. So let's say, for instance, right, you went to the right 8 and you went back 3. So this is a vector. This is 8, 0. This is also a vector. This is -3, 0. And what happens when I add these 2 vectors together? What do I got?
You add them together?
Mm-hmm. If I add going to the right 8, which is 8, 0, adding it to going to the left 3, which is -3, 0, I get 5, 0.
Oh, 5.
Right?
Yeah.
5, 0 is this vector. Starting here at the origin and going to the right 5. Do you see how this distance 5 going from here to here is the same thing as the displacement of going to the right 8 and to the left 3?
Mm-hmm.
So, and it's the length of this vector, technically. This vector is in 1 dimension, so it's very easy to calculate the length. You're just like, all right, cool, that's what it is. It's whatever the number is. When things are diagonal, okay, it's a little bit more complicated, because what we've done is we've converted these things to vectors. We've added them together the same way we would have done this, and we've got what's called a resultant vector, which is like the overall change in position that I have. And that ends up being this. Okay? But in doing that, I've only got the components of that. I know that that overall distance from start to finish is -34 to the left, and it's -142 down. But that's not the total distance, right? That's just the components of it. This right here, the hypotenuse, this is the displacement.
So don't you do, what's it called? Tangent?
Close. So if I want to figure out the value of this, right? This is a right triangle. How do I figure out this part of the right triangle? It starts with a P.
Wait, I don't know. Wait,
Pythagorean theorem. Yes. Because look, Maria, I have one leg. I have another leg, so I can find the hypotenuse. If I just do that squared plus that squared equals this squared, right? Good?
Yeah.
Yeah? You tell me if it's not making sense.
I do remember this.
Okay,
I
good.
do remember doing this.
I know where the tangent's coming in. I'll show you the tangent in a second here, because you're thinking about the angle.
Yeah.
Yeah. So this is 142.5 squared, and then this is equal to what we're going to call is like the displacement squared. So I have to square these, add these, and then square root them to get the actual displacement. So we do that. Again, you can pull your calculator out and do it out. So I'm going to do that squared, and also get rid of the -1 because the calculator is dumb and it sees as like, oh, wait, why is my, come on, there you go, okay. And then plus 34.95 squared. Calculator does not want to work today. Come on. Come on. Good. Squared. And then we're going to square root that. Cool. And we get 146.72. Okay, so the displacement, and that's what you got, right? 146.72? Yeah. Nice. Okay. So, 146.72. Nice. Yes, Kato, please stream chemistry. Yeah, and talk to JC. Actually, yeah, wait, shout out to JC. I didn't see her. Thanks for coming by, JC. And actually, wait, one thing I'll do for Kato, one second, I'm going to tag you just so I can give you the role. What the fuck, sorry. One sec, let me give Kato the right role. Here, let me give you Actual Educators, Chemistry gods. There's a channel, Kato, in the Discord for people who like teach or like are looking to stream teaching and stuff. Feel free to like discuss any collabs you want there, or you can DM each other. I don't really care, but it may be of interest to other people. So, all right, cool. All right, so we got the distance, we got the displacement, right? Yeah, your time zone. How do we get the average speed then?
Distance divided by time, because it's 5 minutes, so 300 seconds.
Very good. Yep. So it's distance divided by time. So that ends up being 285 over 300. And then what's the average velocity? Ooh, this is actually interesting, yeah.
Oh yeah, velocity and speed confuse me. Like what?
So
what's the
velocity
difference?
is displacement over time. Okay. Which we figured out the displacement, right? The displacement was 146.72. And that's over 300. Right?
Yeah.
Okay. Is that the same answer she got? Probably, right? Yeah. I don't want to pull the calculator to do the numbers, but
Yeah.
let's see. Oh, we have to do the angle. Okay, I'll show you the angle. Let me show you the angle. It's okay. Yeah, yep. Got you. All right. Okay, so 285 over 300. That gets you 0.95. Cool. So 0.95 meters per second. And then the other one is this over 300, which is 0.49. But yes, here's the key thing. Velocity is a vector, Maria. Okay? What does it mean for something to be a vector? What do vectors have?
I got no clue.
I got no clue. Good. It has a magnitude and a direction. Yeah, very good. All right. This thing we found here, the 146.72, which, again, then we divide by 300. This is a magnitude. This is, like, the amount of the velocity. But velocity also has a direction, so I have to say which way it's going. Right?
Yeah.
In this case, when we're doing things in one dimension, right? Notice how we said that the displacement was 5. This technically does have a direction because plus means to the right and minus means to the left. So, in this case, you did say that, like, there was, like, a velocity because you're like, oh, well, it's positive, so it's to the right. In this case, the direction is not as easy. It's not just left or right because it's left, right, and up, down. So, one way to do this would be to give her these answers, but like divide by 300, and say those are the components of the velocity. But when your teacher asks for direction, they're usually asking for like what this angle is. Okay? All right. So, to figure out this angle, right, I'm going to like label this here as this. And I'm going to think about what are these two sides that I have, right? So if this is a right triangle, and this is my angle theta, what is this side? Is it an opposite, an adjacent, a hypotenuse? What is it?
Opposite.
Good.
Good job.
This is an opposite. What is this?
Adjacent.
Adjacent, good. What trig identity has opposite and adjacent in it?
Tangent.
Tangent.
Yeah.
Right, tangent. Yeah, good. So I'm going to say the tangent of theta is equal to the opposite, which always make these numbers positive. I'll show you why later. This is 142.5 over 34.95, okay? But I want to figure out what this angle is, right? I'm trying to figure out what this angle is. How do I get this angle?
Divide.
So that is a good intuition. A good intuition would be like, let me just divide by tangent, right? But unfortunately, no. You can't just divide by tangent.
Inverse tangent.
Inverse tangent, yes. No, everyone always does that. Yeah, there you go. It's inverse tangent. Because here's the cute thing about inverse tangent. When I take the inverse tangent of tangent, they blow each other up. So this like goes away, and you're left with just theta. Yeah, Kato. Yeah, we literally were. Yeah, Kato in my chat was literally pointing out when like students just divide by cosine. I'm like, yeah, I know. Yeah. It was predicted. Also, it happens all the time. Everyone fucking does it. All right, so I just need to. Okay, so here's a key thing. Also, in your calculator, make sure you're in degree mode, and you're gonna do arctangent of 142.5 divided by 34.95. And that got us 76 degrees, okay? How do you even calculate it? You need a calculator, honestly. You can't really do it by hand. It sucks. Okay. So theta is equal to 76.2 degrees. Of course, Becky. I'll take a look at it. Thanks for uploading, Becky. Becky, how long can you hang around on the stream? Just so I know if you have to leave. And I can try to, like, expedite it. Okay, so that's 76.2 degrees. But then your teacher probably wants to know in reference to what, right? So... we said this, right? When this was 30 degrees, that was north of west. So this is now 76 degrees. And then, how do we describe this movement here? What is it? Oh, you redeemed the me first. Oh, okay, then I will do yours first, Becky.
My man.
It's south of west, right? Good.
Yeah.
Nice. Okay, perfect. So yeah, so it's this, and then you say 76.2 degrees southwest. This is like south of west. Cool. Does that make more sense?
Yeah.
Nice. Okay, yay. Good job, Maria. Cool. I'll save all this and put it in the... I'll tag you in it too. So you can like look at it later.
Okay, thank you.
You're very welcome. Do you have a test coming up soon?
Tomorrow, actually. It was supposed to be Friday, but I skipped because I didn't know what I was doing.
Oh, okay.
Like, I'm not gonna risk it.
Yeah, well, that's a totally legit strat. Yeah, if yeah, rather than just getting murdered, right?
Yeah.
Just be like, can I take it later? That's totally okay. But yes, let's make sure you know this stuff for your test coming up. Cool. Feel free to ask me like other questions. Like if you're still around and I'm here on the stream, I'll do more questions to help you out for it. Okay, cool. Nice. And then here, let me tag Maria in this one. Maria. Then we're gonna say physics, office hours. There we go. Thanks, AA. Oh, Mathematic Fanatic. What's up, Fanatic? Good to see you, Waldo. All right. Let's see. Becky did redeem. Let me do this one first, and then I'll do yours, Becky, just because I already did a skip real quick. But let me do this one, and then Becky, you're next. I appreciate you redeeming the me first thing. There are benefits to watching the stream on Twitch. You can redeem power-ups so that you can like skip the line. How do I understand torque? Torque is R perp F or F perp R. Okay, show that F is a conservative vector field on R3. Okay, so I think if things are conservative, I literally just did this with a student. I think what you do is you say like dfx dy is equal to like dfy dx. What's going on, Riley? dfy dx. And then you also have to show that like dfx dz is equal to like dfz dx. And then I think the final one is dfy dz is equal to dfz dy. How do you submit questions? There's a website there, actualofficehours.com. I will do them. Okay. So these are all pretty nice integrals. So like, or derivatives, sorry. So this, for instance, I need a different color, sorry. Is that equal to divergence?
Nice.
Is it? I don't think it is. Is it? Div? Divergence is equal to 0? Divergence is the dot product. Isn't this divergent? Is this div dot f? Let me think what that is, sorry. That's dfx. No, I don't think it is. Is it not? I don't think so. Okay, so doing this one, or so this is fx. Curl is 0. That's okay. Yeah, this is curl basically. Yeah. That's what I knew it was one of them. Yeah, curl f. This is curl f. And then this is fz. Okay, so dfx dy, that's just 2y. And then dfy dx is also 2y. Cool. Dfx dz is 2x. dfz dx is also just 2x. And then dfy dz, that's 1. And dfz dy is also equal to 1. Nice, cool. So yes, they are all conservative. Find a potential function. Okay, this is always fun. I love these. So what we say is that curl of f, sorry, nabla f must be equal to big F, where this is a potential function. And so what that says is that like df dx has to equal to fx, df dy has to be equal to big Fy, and then df dz has to equal to big Fz. That's what this statement means. This is always, nabla is the directional, not directional. Is it directional derivative? I feel like it kind of is. Yeah, it's a directional derivative, right? Because it's a derivative in the direction with reference to the direction. I think it's a directional derivative. Okay, but from this is really cool. Because what you can do is I can move this over here. This is Calc 3 for sure. And then I can integrate both sides, right? And so once I integrate both sides, okay, integral df is just little f. And then this is equal to the integral of fx dx. So this up here was fx. So we're going to do the integral of y squared plus 2xz. 2xz. And then that's all dx, right? So let's see what we get. So that gives me, this is a constant with respect to x. So integrating a constant just pulls out an x. So I get xy squared. And then this becomes x squared over 2. So that becomes plus x squared z, because then divide by 2, right? That goes away. And then the cool thing is this is plus another function g, or like, yeah, let's use g, which is a function of y and z exclusively. Because when I integrated this with dx, this is because this is an indefinite integral, there's also the possibility of a constant. And that constant has to be a function of just y and z. If it was a function of x, it would have gotten messed with when we did the integral. Okay, so then I'm going to do the same thing for this one. I'm going to say, okay, cool. Well, f is equal to the integral of fy dy. Here, this is f is equal to the integral of fx dx. And then fy was 2xy plus z. dy. So if you integrate that with respect to y, this becomes xy squared over 2 plus yz. And then that's plus a function, which we'll say at h, which is a function of x and z. Okay, cool. And then we'll do the final one here. I know there's another way you can do like the derivatives and stuff, but I kind of like this way. I think it's a fun puzzle. So this is fz dz. So that's equal to what's that? X squared plus y plus 3z squared. dz. I use Wabbit Emu. You needed a 70 on the final to pass the course. Did you get the 70, bro? Aleph, did you get it? Tell us you clutched it, bro. Okay, this integral is just x squared z plus yz plus z cubed, and then this is plus some function I as a function of x and y. Cool. All right. So now I try to like look at what super function satisfies all three of these conditions. Well, website's not working. Oh, it should be working. Yeah, this is the way. Just do all three and put them in overlap. Yeah. Looks like it is working, Ain. Let me know if it's not. Or anybody else want to check. Okay, so from here, look, x squared y, something as a function of x and y. That's okay. Great. I cannot do ODEs, but I have people that can. So, Camille, if you want to submit a question anyways, it'll get passed off to one of my friends who can do it. Yes, also, yeah, for those that are watching, I always like to do little announcements, but the website is actualofficehours.com. You can upload a screenshot of your question. Also, if you want to figure out all the other times we're streaming, click here on streaming schedule, and that'll show you a calendar for everybody's streams. So we're on today. Zach will be on tomorrow morning doing some software. We'll be on Monday as well. I'm waiting Joseph. Joseph, when are you streaming, dude? I know you're streaming one of these days. But you can find out all the other times that other people are streaming who are awesome. And then also join our Discord if you want to see all the questions and what's happening. Yeah. Yeah, I don't like the integrating and differentiating. That part sucks, right? Okay. X squared y, something with an x and y. This is okay. Then I see x squared z, something as a function of x and z. That's okay as well, too. So, also plus x squared z. And then I see yz, something as a function of yz. We're good. So, plus yz. So then that's it. I'll need to figure out when I'm free before I'm... Yeah, all good, all good. So yeah, it's good. So this is the function. We figured it out. Super cool. So then if you want to compute the line integral, this is where this is beautiful. I forget if this is Green's theorem or something, but if you have the potential function, rather than having to do this as a line... This would suck. Like, this is like... Bro, there's so much stuff going on.
Disqualified.
The integral of like big F dot dr, which in this case is the same thing as the integral of grad F dot dr. This is also just equal to, and let's say this goes from like A to B. This is the same thing as little f of B minus little f of A. What theorem is this called again? I know this is the fundamental theorem of calculus, but is that kind of what this is? Because this is the integral of like a directional derivative. There's some name for this, but the whole reason you do this by showing that the vector field is conservative and finding a potential function is that in order to do a line integral, I don't care about the path. I only care about the start and the finish. So now I'm just going to do f of 2, 2, 2. So little f of 2, 2, 2. I need help for my math class. I'm a senior in high school. Cool. You came to the right place. Submit a screenshot of your question. I'll go through it. So F222 minus F1111. So now we just plug these all in to stuff, right? So this is 2 times 2 squared plus 2 squared times 2 plus 2 times 2 minus, that's 1, 1, 1. So minus 1 plus 1 plus 1. It's just called the gradient theorem or the fundamental theorem of calculus for line integrals. Wow. I thought it was like Noether's theorem or something. It's like least action or some shit. I forgot. So this is 8 plus 8 plus 4. So that's 20. Minus 3. Answer is 17. Nice. Cool. It's math. It's not maths. It's math. Math is math. Good question, Fathom. I like that. That was a really fun one. I literally just did that with a student the other day. That's actually pretty cool. Heathen Brits. There's more than one type of math, though. I get, like, mathematics. But, yeah, no, we call it just math. All right, Becca, you're next. Let's do this. TikTok doesn't believe I'm real. Give me a second. Always have to solve a CAPTCHA. Like, this guy can't be really teaching for this long. No way. No way. Cool. All right, Maria, let's see. What do you got? Or Becca, sorry, not Maria. Becky. Okay. Becky always asking the fun ones. TikTok does think I'm a robot, yeah. Well, I mean, we have been streaming for an hour. It does it at the hour mark. It's always like, yo, what's going on here? Okay, Becky. I love how you say, yeah, here, solve my question, but then you ask me a question that I probably can't solve. Let K, M, and N be natural numbers. Suppose that N and M are co-prime. I don't know what co-prime means. They're prime with each other. What does co-prime mean? Good night, bro. Feeling sleeping. Good to see you, AA. New sound effects did drop. Yeah, I've been adding some slowly. I've been adding some new sound effects. Co-prime, the greatest common denominator of N and M are 1. Oh, okay. So, like, could we say, like, 8 and 9 are co-prime? Right? Because these divisors are 3s, and this is like 2 and 4. Oh, they're very cool. Nice. I learned something today. Okay. But 8 and 10 are not, right? Because they share 2. Okay. Consider the polynomial defined by a0 plus a1x plus blah, 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 8 for every x. Every x which is real. Suppose that p n over m. Sorry, what's p? Oh, wait. Oh. P n over m is equal to 0. Prove that m... What is this? M... to me, this is like conditional probability. What's m bar ak? M divides AK. So like AK can be divided by M. M is a factor of AK. What am I looking at? It's a very good question. Okay. Yes, Kishan, I can help with residue theorem. Okay. What'd you say, Jeff? Oh, that's cool. Thank you. I'm totally not .com for coming in and saying that in our chat. I appreciate it. I didn't know what it means divides. Fundamental theorem of arithmetic unique factoring. Oh wait, I missed a term. Did I? Fuck, really? Oh, I missed the z cubed. Shit. My bad. My bad. Okay. So that's plus 8 minus 1. So that's 28. Sorry. Yep, thank you. Thank you. 28 minus 4. So it should be 24. Good catch. Let me fix that. Damn, you draw 4 like that? I do. Is that like a oh, thank you, Keyshawn, for the roses. Is that like a bullshit way to draw it? Thank you, Kensakia, too. I don't know how to do this one. Becky. Means that a to the k equals m times n for some integer n. Number theory. Yeah, okay. I'm going to pass on this because I can't figure it out. And I only have an hour and 37 minutes. But I appreciate it. It's cool. I'm going to put it in my Discord. I'm going to have the math gods go after it. But always fun. Always fun to have a little challenge. I like seeing like what I know and what I don't know. I obviously don't know number theory. Okay. Right here, let me make this unsolved. I'm gonna put this for math gods. What's your Discord? So there's a link. So if you go to the website, actualofficehours.com, go to this website, click join our Discord. There's a link right there to go join. You were stuck on this question for like an hour? Okay, I'm gonna tag the math gods. I'm gonna tag him. Calling in the heavy artillery. That's from your calculus class? Get the fuck out. No. Dude, what? Were you taking like a calc class from hell? The hell? Alright, let's see. This is a physics question coming up. The link to the Discord is in the website there. Yeah. Go to actualofficehours.com. There's a link there to join our Discord. Femvox has some ideas. It says you could plug n over m into that polynomial and then clear the fractions. But I feel like it was like an infinite polynomial. It went up to like degree k. Got 6 out of 40 on this physical chem question. Oh no. Alright, consider a windmill with a vertical wind tunnel rotating in a horizontal plane consisting of 3 bar-like rotor blades. Okay, cool. Each blade is 20, has a mass of 150. It is required that the rotational speed of the blades be slowed down. One idea would be to add several discs of radius 0.25 meters with mass 50 to the axle of the windmill. How many discs would it take to slow the windmill by half its initial angular speed? Hint, apply the principle of conservation of angular momentum. Yeah, for sure. Well, yeah, okay. Angular momentum is L is equal to I omega. So, assuming these are placed on and there's no like force when they throw them on, that means that I1 omega 1. But if we want it to be half its initial angular speed, this needs to be equal to I2 omega 1 over 2. Okay. So let's figure out what the angular momentum would be. So so for 3 of these rods, about their ends. So this is about the ends. I don't know why they say it's center of mass. I don't really care about that. So I of a rod is going to equal to 1/3. The mass is 150. And then the length of it is 20 meters long. Does Terry Davies have divine intellect, meaning he's the greatest programmer of all time? I don't know who that is, but Samsung, don't spam the chat 3 times, please. Okay, but then there's 3 of these rods. Oh, that's actually kind of convenient. It's 1/3, but then they gave us 3 rods, right? So in this case, when we don't have any of the discs on it, yes, they do need to add one. And there's a video of me. I asked the CEO of Twitch at TwitchCon to add one, and he said he would DM me. He hasn't DM'd me yet. Dan, if you're watching, dude, on Twitch, bro, you told me you were gonna DM me. You haven't DM'd me yet. Okay, so anyways, this is just gonna be 3 rods. This is just 3 rods. Am I a teacher? I do teach. DM him. Yeah, come after his DMs. Yeah. Yeah, let me just casually DM the CEO of Twitch. Just be like, yo, bro. The fuck are you, dude? You said you would talk to me about this. Okay, so this is times omega 1. Okay. And then this is equal to... Is this your job? It's one of my jobs for sure. This is 3 rods plus n plates. Or discs, I guess, right? Okay, and then we have that I for a disc is equal to 1/2. The mass is 50. And then the radius is 1/4 squared. Radius is 1/4, but then r squared, right? Cool. So that's cool. That's 25 over 16. So that's going to be 150 20 squared plus n times 25 over 16. And then this is all times omega 1 over 2. Yeah, Dan just watches thirst content. Apparently, I don't know. Okay. Okay, all stuff is solved for n here, right? Does this make sense? This is like now I total. You know, he's a very friendly dude. I've talked with him, you know. I got like kind of a standing ovation at TwitchCon when I said that, hey, I teach high school kids math and science on Twitch, and like, where the fuck is an education category? So I'm just waiting for Dan to get back to me. He's a very approachable guy though, for sure. So then the 2 comes over. And then we're going to subtract this. $20 squared. Yeah, Samsung, why does your chat come in 3 times, dog? Check your phone, dude, please. When you chat something, it comes in 3 times on the chat. Okay. And then it's that minus that. Okay, cool. Is equal to n times 25 over 16. Well, I don't know what the question is. Submit as a screenshot. I don't answer things in chat because there's too. I'll answer some things in chat. I can't answer math questions in chat. There's too much going on. You're more than welcome to pose the question in my Discord, though. Go join Discord. All right, so let's get some numbers for this. I think we're pretty much done with this. Let's see. I need my calculator to work. It just doesn't work sometimes. Okay. Oh, so 2 150 220 squareds is just minus 1 is 1. So 150 times 20 squared, which is 400. Cool. That times 16 divided by 25. Dude, that's a lot of fucking plates, dude. What? 38,400 plates? Oh, Jesus. That doesn't seem right. Right, chat? Dude, what? That many plates? That's way too many plates. Let's make sure we did this right. I omega equals I omega, right? Yeah, and omega's over 2. I mean, the discs don't really have that much angular momentum. That's the issue. That's a lot of discs. Like, the blades are just 3 blades. What's your opinion on Calculus 2? I like Calculus 2. I think it's better than Calculus 1. Calc 3 is the ultimate calculus, though, right? Or maybe it's like the Matrix, right? The second Matrix was the best instead of the third. Or Star Wars. They always say, like, The Empire Strikes Back is better than Return of the Jedi. Yeah, I think this is it. I mean, it's pretty ridiculous how many blades you would need, but let's throw this in the chat real quick. I just want to see what it gets. Just to make sure I'm not crazy. Calc 3 is the best calc. Yeah, one idea is... Okay, I see. Yeah, so you would reject this. Reject.
Surprise, motherfucker.
Like, this is a bad idea. There's no way you're gonna get 38,000 discs on this thing. Dude, also, what is up with ChatGPT these days, dude? I need... We're going back to the legacy models, dude. ChatGPT 5.1 is, like, blowing. Like, there you go. Look at this. This does it. 5.1 sucks, dude. Yep. 38,400. Cool. Yep, cool. All right. I know I'm correct. It just seemed ridiculous. Nice question. That was Ryu. All right, I'm gonna throw this answer into our Discord. Where is Ryu's question? Come on. Reject. It's a bad idea. Don't do it. And then this one. I wonder how many problems you've solved on stream now. I mean, now we can keep track of it because there's a forum for it. I want to add up how many I did during the 10-hour stream, honestly. Definitely not Leckel. Definitely not Leckel. Oh, man. Definitely not, dude. You just joined? We're starting a new problem. We were doing like a angle run. This is great. I'll come back here once my professor starts. Yeah, please do. JU, Jew, whatever you want to be called. Yeah, we do a lot of different types of questions. Definitely E&M. A particle has a wave function this where n is normalization and alpha is a real parameter. Calculate n. So I know that lambda star lambda has to be equal to 1, right? So, but this doesn't have any complex components to it, right? So the integral of n squared e to the negative 2 alpha r, right? dr has to be equal to 1, I believe. And then this is a Gaussian integral, isn't it? What's the Gaussian integral? It says good luck, dude. I mean, I'll do a couple of them. I only have an hour and a half left, and I still got a lot of questions. There you go. This is what I want. It's definitely not my question, Leckel. Okay. And then this is from negative infinity to infinity, right? Is it not a Gaussian? I thought this is the Gaussian integral. Oh, but it's not. Oh, you're right. It's not. Normal curve. Well, Jeff says it is. Someone says it wasn't. I think it is a Gaussian. Yeah, I think it is. Although, yeah, actually, he is right. It's not, because the power is not squared. Thanks, Sam. Sam is correct. Thank you, Sam. So we don't need this. Okay, yeah, because actually, this is actually not a bad integral, right? This just becomes n squared over negative 2 alpha, right? And then it's e to the negative 2 alpha r from negative infinity to infinity. It's almost Gaussian. Yeah, well, it's not technically it's not Gaussian. Okay. So, Jeff's like, I'm fucking pulling it out, dude. What type? What is Wolfram saying? Yeah, that's where it's squared, though. Yeah, has to be squared. It is orthogonormal. Orthogonormal, that's a new one. I know orthonormal. Orthogonormal? Okay. So this is 1 over e to the infinity minus e to the infinity. Well, that's not good. No. Wait, how does this work then? This is discontinuous here. Unless this was defined only from r equals 0 to infinity. When are we getting more astrophysics and chem questions? Probably soon. Check the queue. Use the time integral. Wait, there's nothing with time in here, dog. What? All right. I'm going to tell chat to go help me. Chat, go help me. Yes. Oh, it is absolute value. For spherically symmetric. Uh-huh. Oh. Oh, this isn't one-dimensional. Oh. I see. I see. Tricky. I thought this was a one-dimensional wave function. No, it's a three-dimensional wave function. Okay, but I was on the right path, right? Is that a GCSE question? Yeah, maybe. Oh, the last question in the queue. I see. Okay, so yeah, it's 4 pi r squared dr, and then you go from 0 to infinity. Very cool. And then you have to, this is an identity for certain types of integrals where it's of the form r squared e to the something r. This is graduate level quantum mechanics. This question is hard. Oh, thank you, Faizan. Thanks for the jewels. Okay, you plug back in, and you get that. Okay. Cool. What's up, Faizan? Here we're doing a little bit of quantum mechanics. And then, okay. Residue theorem. Oh, this is not the residue theorem. But I think someone submitted a residue theorem question. This is one of the questions on your quantum mechanics final. How would you figure out from the question that it's not 1D? I agree, Claire. Yeah, I thought it was a 1D thing, and I was like, wait a minute, but this wouldn't work, right? Because usually when I do quantum mechanics, this is a graduate level quantum mechanics class, but I guess you're supposed to notice that R usually means spherical, and so it's a spherical wave function. You have 5 minutes for each part. Yeah, I mean, okay. The expectation value of X, though, what? I can do the expectation value of R. What is X? Yeah, Claire. No, totally. Okay. I have a lot of questions in the queue. Let me come back to this one, Leckle. Just because graduate level quantum mechanics I don't think is really my expertise right now. But if we have time, which I think we will. Just let me make sure I get through everyone else's questions. I'll come back and do this. This is cool. I like quantum mechanics. Oh man, people asking me engineering questions. Principal stress? No. Okay, this one is automatically getting put into my Discord for engineering people. X's position, yeah, but what's the difference then between X and R then? That's my question here, Leckle. Isn't this also the position? And yeah, if it's spherically symmetric, would X be 0 then? Because X can have positive and negative values, but then this is technically the distance. X is like the X position, yeah? R is like absolute value of X. Well, it's absolute value of X squared plus Y squared plus Z squared technically, but yeah. But here, Daniel, I am gonna I put your post in our Discord, and I gave it to the engineering gods as their tag. So we do have some people in our Discord who have engineering degrees, or they work in engineering, and they can probably help you out with it. Okay, let me see what the next one would be. Ain. Okay. I think I like this. This looks like physics. The sledge is pushed to the bottom of a ski slope. This is the plane at an angle of 15 degrees. You're a quantum engineer? I don't know. Are you... Did you get pinged? I think maybe you told me you can help out with engineering. Okay. The sledge. Dude, what is a sledge? It's like a I know a sledgehammer. It's like a... Did they mean like a sled? It's like a sled, okay. Oh, sledge is British for sled. Oh, you Brits.
Bing, 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 bang.
Okay. Alright. The sled is attached to a light rope to a winch at the top of the slope. The rope is parallel and has a constant tension of 200 newtons. And the sledge is partway up the slope. The ski slope is smooth. Show that the sledge... I'm never going to get over that, dude. The sled has moved from being at rest at the bottom of the slope to the point where its speed is 8 meters per second. It is... Sorry. Okay, when it's moved from 0 to 8 meters per second, it has traveled a total of distance of this. Cool. And is there any friction? Assume there's no friction, right? So, one way to do this, right, is that net work, right, is equal to the change in kinetic energy. Where net work is the same thing as F net times the distance. Equal to the change in kinetic energy. So change in kinetic energy would be 1/2 mv final squared minus 1/2 mv initial squared. So that's equal to 1/2. I guess we're just gonna say whatever. M. And then v final squared is 8 minus 0 squared. I panic so much, dude. I would panic, dude. Okay. And then F net. Okay, so we think about all the forces on this. And I only care about F net in the direction of the distance. So I really only care about forces that are in this direction because it's moving that way, right? So, key things is that you have a force of gravity pointing down, but then that has components. And so this part right here is mg sine theta, or mg sine of 15 degrees. Okay, so F net is going to be equal to mg, or it's equal to 200 minus mg sine of 15 degrees. And then we're going to say times the distance. And then we say the distance is 13, I guess. Or here, let's just set it to d and let's solve for d. Boom, boom, boom. I want to see if this like cancels out or something, but okay. So 8 squared is 64 divided by 2, 32. 32m is equal to... I don't like this. I don't like there's still an m in there. That's not good. Do I have the mass of the slope? I don't have the mass of the sled, though, do I? What's up, Motion? Good to see you, dude. Been a while. Think, right? Yeah, mg sine 15 degrees. W net is force times distance, which the net force is the 200 minus mg sine 15. That's equal to 1/2 m times that. Oh, okay. All good, dude. Okay, let's just say that d is equal to 13. I don't know, fuck it. Let's just see what happens. Maybe it cancels. So, let's say 200 times 13 minus m times 13. Well, actually, you know what? I can divide the 13 over. Oh, I know what I'm going to do. I know what I'm going to do. Gravitational potential energy? I don't think so, because this takes into account, I think, because I want the network dot the times the distance, but it's the work in the direction of the distance, right? I probably could do it with kinematics. I want to do it this way. I think it's cool. My question is, how am I going to get rid of m, though? Hecka, hella, holy crappa, yeah. How many cheeseburgers per bald eagle freedoms? Bald freedom eagles. Because this takes into account, this mg sine 15 times d, this takes into basically the potential energy. It's the work done by gravity. Right? Because think about, like, so d sine 15. So if this is d, sine of 15 degrees tells you this, and then it's mg times that. Okay, whatever. I'm just going to see if it works. So 200 minus m times 9.8 sine 15 degrees is equal to 32 over the distance we traveled is 13. I don't know how I'm going to get rid of the m's, though. Yeah, m's don't cancel out, though. That's a problem. M's do need to cancel out. I think the issue is because I have a force here that doesn't have m in it. Okay. Let's try to do it without doing my conservation of energy. Or whatever. Okay, so F net is also equal to mass times acceleration, which is equal to m delta v over. Well, let's leave the acceleration for now. And that's equal to. Man, I still have the m's though, bro. How the fuck do I do? Oh, well. No. But in part 3. Solve for m. How do we solve for m though? F net times m equals 640. Yeah. Oh, that's another key point here. Yeah, wait a minute. Yeah. This is question part 3. Where's question part 2? And question part 1. I feel like I need knowledge about the fucking sled. I need the mass. You have to have the mass of the sled. I can't solve this unless I have the mass. Oh, I see. Because even when I'm looking at this, right? If F net is equal to this, I'm still going to get 200 minus mg sine 15 degrees. I need the mass because there's no mass built into this. It's incomplete. Ah, fucking fuck, dude. I knew there was something wrong with this question. Oh, man. Who submitted me a question but didn't give me the mass? Because, like, this works once I have the mass. Can we go find this question? I want this one. I want it now. Gold is tilting. Well, man, because I don't like feeling dumb when it's not my fault. Like, this is not my fault. This is because I was given an incomplete question. Okay, one sec. Let me see if I can find the question. No exact matches. Ooh, okay, what? Here, it is a GCSE question, though. I think we found it. Yep. Motherfucker. The sledge has a mass of 40 kilograms.
That's dope.
Oh, look at that. Look at that. That was neat. That was necessary. God fucking damn it. I was looking at this, I'm like, fuck. I can't solve this without having a mass. And then, yes, someone pointed out that I was giving part 3. Fuck. Stop. Okay. Alright, fine. Friction is also not negligible? What did they say? Oh. Okay, dude, there is so much. There is so much missing in this question. Okay. Alright. Ain, you gave me an incomplete question, dude. Okay, so 100 newtons of friction, and it's also 40 kilograms. Is what we have to know, right? Oh, wait, no, it says the ski slope is smooth. I assume this means there's no friction then, right? Oh, this is when it's flat. This is deep snow. You just realized I have a beard? What? I've always had a beard. What? Well, this is in GCSE mathematics, so it's not further maths. It says mechanics. This is where it comes from. Yeah. My oh my, that's why. Okay, so this thing is 40 kilograms. Okay, m equals 40. That was useful information. Okay. I'm not gonna get upset. All right, so D is equal to 32 times 40 all over 200 minus 40 times 9.8 times sine 15 degrees. That should work out. Okay. Let's get this in here. I love Excel. Excel's great. Curly doesn't like Excel. If you go say hi to Curly, she hates Excel. Did you guys like Thug Shells the other day? The rap artist? She's hilarious, isn't she? She's a fucking gem. I love Thug. She was doing the different... She can rap like any word. I didn't realize she also did the science stuff. Okay, there we go. D is equal to 12.98. 13 meters. Nice. Check. I don't know. She just hates Excel. And she has a math PhD, I think. She's an engineer or something now. Yeah. Cool. Beautiful. Oh, this is kind of a fun question here. Find the time between the rope breaking and the sledge reaching the bottom of the slope. Ooh. Okay. Okay, this is part 4. So you have, and they want to find the time between it breaking? Okay. So it needs to travel 13 meters down the slope, right? So acceleration is just going to equal to, and here, let's define a coordinate system real quick. I'm going to call this negative. I'm going to call this positive. And I'm going to call this 0, right? This is like x equals 0 per se. So then negative 13 is equal to 0 plus v initial. So initially it's going up at 8. So 8 times t. And then minus 1/2 times the acceleration. Well, the acceleration is just gravity in this direction. And that's negative mg sine 15 degrees. Or no, sorry, negative g sine 15 degrees. Sorry, we don't have the m in it anymore. Because that was the force. F over m is equal to a. Okay, cool. So, whatever, plus, and then it's negative g sine 15 degrees t squared. The tension equals 0. Yeah, once it snaps. So once it snaps, now you no longer have any you don't have any tension trying to pull it up. It's just falling down. So this gives me, what is this? 4.9. I don't know what the sine of 15 degrees is. What's sine of 15? That's not anything nice, is it? Yeah, 0.26. T squared minus 8t minus 13 equals 0. Cool. You have a lot of math memes. We've had meme channels before. Now here's a question. On the GCSE, do you get a calculator? Are you allowed to use a calculator on this? I feel like you kind of have to have a calculator to solve this. This is a nasty quadratic. Kato says yeah. Okay, cool. Okay, so What's that? You guys want to give me one? I think it'd be kind of fun. Hopefully this like crosses at like some nice time. There you go. Calculate the 0. You get t is equal to 7.62. Cool. Nice. All right, we did it. Good question. You got any theory of computing knowledge, my man? What is the theory of computing? All right, let's see. Whose question was that? That was Ains. Mark that as done. Which digital calculator is this? That's a TI-84. This one right here. It's an emulator of a TI-84. It's a gold one. What's up, Poisoned? It's so proud of you, Kato. What's new? We're going through some questions. Let's see, who do we got? Rivers next. Okay. Who's this cute little thing on the right? What do you want to ask about this, River? Oh, you want to come to the stage? All right, you can come up.
Yeah. Can you hear me?
Yeah. Yeah, I can hear you. What's up, dude?
I would share my screen. So I had a question that was a solution to x to the power of pi is equal to pi to the power of x.
Oh, okay. X.
And I was trying to solve it.
X is equal to the power of pi, which is equal to pi to the power of x.
Yeah, and then I rewrote it as x to the power of y plus pi, and then y plus pi to the power of x. And that gives you that graph, and if you move it down, you see that you get two real solutions.
I see. What,
And
at x
so-
equals e?
X equals e is just the middle point. So
Oh, okay.
as long as it's that they're two real solutions.
Oh, okay. Oh, okay. Okay, wait. I think I see what you're saying. Okay, so you have this. My gut instinct when I see this is to take the ln of both. I mean, x equals pi,
Well,
obviously.
I can
Yeah.
walk you through how to solve it algebraically.
Okay, so what do you say?
So take natural log of both sides.
Yes, I like the natural log of both sides. That's what I wanted to do. And so this gets us pi ln of x is equal to x
and
ln
then,
of pi.
Yeah. So
Okay.
bring out the x and the pi.
Bring out. You mean like move them over?
Yeah, bring out. You already brought them out. So then you divide pi and x to
I
both
think-
sides, and then
Yeah, I think I want
to
to do this. Yeah, so I want to do ln of x over x is equal to ln of pi over pi.
Yeah.
Which, yeah, one easy solution here, right, is x equals pi. Right?
And
Eh.
the identity is e to the power of ln of x. So you can do that for that sign. Or,
Oh,
yeah,
I
so-
see. No. I think I see what you want me to maybe rewrite this as ln of x to the 1 over x.
No, ln of x over e to the power of ln of x.
Okay, let's try that. So ln of x over e to the ln of x. I agree with that. Sure.
And then is equal to ln of pi over pi.
Okay.
So, and now you would make it a negative exponent and put it on the top.
Okay. So I get e to the negative ln of x. Ln of x is equal to... Do you want me to say pi to the negative 1?
No, it's still over pi. But
Okay.
you forgot the first element x. Or, no, you just wrote it weird. Do you know the product log or Lambert W?
The Lambert W, they say. I don't.
So the identity is W e to the power of W is equal to another variable.
Let me find this. Lambert W.
Yeah.
Lambert W came up yesterday. What did it come up in, Jeff? When did we learn about Lambert W, dude? Where is it? Oh, here it is. Is this it?
Yeah. Yeah, that's the one.
Okay. I'm just gonna copy this. Okay. So WZ e to the WZ is equal to Z?
Yeah.
Okay. But this is in this case my
almost in
WZ
the
is it's close, right?
Can you switch around the e to the minus ln of x and the ln of x?
Yeah, sure. I can say ln of x e to the negative ln of x.
Yeah, and then you just multiply both sides by -1.
Oh, I see. Okay, because now this is the same as this. Oh, very smart.
Yeah.
Okay, so now this is, you say like WZ is equal to like negative ln of x. Got you. Or WX, sorry, not WZ, right?
Yeah, so there are two identities, I forgot. If you take the W of Z e to the Z, it's equal to Z2.
Sorry, what's that one called? What's that identity called? That sounds like a cool one.
But they're
Both Lambert
just
W
kind of
identities?
like Lambert W identities.
Cool. Let's look them up. We're learning some shit today. Oh, here we go. These? Are these them? This looks kind of like weird.
I haven't seen that one.
You ever seen these before?
Oh, yeah, I guess we'll need to use that one because I was trying to figure it out and I got one of the solutions doing it algebraically, but I couldn't get the other one.
Okay.
Because
What's up, Sahum?
the function is less than -1.
So wait, this, right, holds for this.
Yeah.
So then WX e to the W of x is just equal to x. So I get x is
Yeah.
equal to the negative ln of pi over pi.
Or
So
you
that's
would get minus ln of x is equal to W of ln of pi over pi. Or can I share my screen?
yeah.
No.
Yeah, you can share your screen. Yeah, you can. I don't care. You
Or
can share your
does it-
screen. Or actually, I don't know if it'll let you share your screen because I'm sharing my screen. Sometimes it doesn't let you like share multiple screens on Twitch, on Discord. Still at it. Let's go. You suck at math. You're good, dude. What's up, bro?
Minus ln of x is equal to W of... I don't know how to write the other identity. So W of a to e to the power of a.
Poison says, I think he wants to go from the second one to the second one. Okay, so W A e to the A is equal to A?
Yeah.
Okay.
So then you'd use that for the end of the green one on the left.
For this one.
Yeah.
So you don't want me to do this. Okay. Oh. Yeah. Okay. Oh, so I take the W of both sides. That's what you're saying.
Yeah.
Oh, okay. Got you, bro. Okay, so then, yes, this is this. So this just is equal to negative ln of x. So negative ln of x is equal to this Lambert whatever the fuck function.
Yeah. It's also called product log, but I don't know how many people
Negative
use that.
ln of pi over pi.
Mhm.
You're okay, Ain. Yeah, we got it. Ain, we did it. I found it. I found the where is it? I found the GCSE question. It was like here. The 40 kilograms was necessary, but we did do it. The solution's in our Discord if you want to go check it out. Yeah, we did it here. We did these two parts. All good, Ain. Lambert WTF. Okay. So then, well then x, right, needs to be equal to e to the negative w negative ln of pi over pi, right?
So go up to the first identity that you pulled up.
This one?
Yeah, you can divide w of z, so you have z over w of z, and that would give you the identity where you could simplify the one on the bottom. So is equal to e w of z.
Okay, so from this, but this is
make sure to
negative.
remove the negative one first. Yeah, remove the negative one using I think product rule or exponent rule, whichever the one where you can like multiply them.
Oh, okay.
Like
So I can say this is x equal to 1 over e to the w.
Yeah.
Negative ln of pi over pi, right? And so we're going to say that this is this, and that's equal to z over wz. So that's equal to negative ln of pi over pi. One sec. Oh, but that's going to be on the bottom, and then you have... Wait. And then you just have... Wait. This is like circular logic, though, bro. What? But then this is equal to... Yeah, this is w of negative ln of pi over pi. Okay. What does that really, like, solve for me, though?
The w you can simplify for one of the identities. That is just equal to pi, if you do the same thing you did with the x. But I guess the second identity, do you understand it? For values that are...
This one? X equals E?
Or what's the first one?
First one is
Because-
W is equal to ln of X over W.
Yeah, it says for values of x that are greater than 0.
Greater than negative 1 over E. This one looks like some sort of like power rule for like derivatives.
Yeah, that's
Kind of.
confusing.
Yeah, this is confusing.
We can get one of the solutions, which is just pi, but how do you think you'd go about getting the second solution?
Dude, I would get this first solution as pi from just fucking plugging in pi at the beginning, dude. I would right here and be like,
that's the easy
bro,
one.
the answer is pi.
But there are two solutions is the thing that's confusing. Like if you look at the graph at the top.
Yes. Well, okay. I see there are two solutions, yeah. Well, okay, so the second solution has to come from somewhere. Well, no, this just tells me x equals to pi then, right?
Yeah, it simplifies to that, but like
What's up, Joseph? You
there are
wanna say
two
something?
branches of Lambert W. What's his
Ooh,
name?
okay. See, I don't know much about Lambert W. Joseph, do you want to come up and talk about Lambert W? I have no clue who this Lambert W guy is.
Yo.
What's up, dog?
Hold on. What's up? I'm on the stream. Yo. Yeah. So, let me just type this out. Do you see the office hours chat?
Yes, I do. Not the stage chat. You mean the regular office hours chat?
Yeah.
Yeah,
I
I see it.
understand the second
Please.
branch.
Paste this into Wolfram Alpha for me.
All right, I got you. Dude. What's up, Roar? Someone said, "What do you think
so
of the
that
formula
should give you
equals?"
pi, right?
Okay.
Oh, sorry.
No, you're good. You're good. You're saying this?
Yeah. So
Product
the
log.
numerical value comes out to be pi, right?
Yeah, the
Yes, that is
negative
pi.
branches.
So that comes out to pi. Replace the -1 with 0 in the
This one right here.
in the input.
Yeah,
Okay.
Yeah. And now you'll get the other real solution.
Oh.
And you can replace the 0 and -1 with any integer. And what happens is, it's because the Lambert W is a multi-valued function. So on the complex plane, you can get many different values to it.
Gotcha.
And depending on which integer you put it, get a different solution. So if you put in like 2 or something, you get a complex solution.
Okay, but we only want the real solutions, I guess, right?
Yeah, but you
Oh
only
yeah, I
want
see.
the
This
real
is complex.
solution.
Oh, so this is why you're saying there's only 2 real branches. Oh, I see. So, oh, that's fucking cool. And it's called product log. That's what the Lambert W is called. It's called product log.
Yeah.
Oh, that's fucking cool.
Joseph, do you know how to get the positive branch algebraic thing?
Like the 0 branch.
Yeah.
I don't think you can simplify that. I think that's just the final form you get.
So I guess
I don't think there's a way to.
that.
It's not even my final form.
Yeah, you'll just have to write it as like W0. And then.
Oh, I see.
Or
Oh, this
just
is
say
cool.
SE.
Oh, this is literally what you just wrote. Oh, thank you, Joseph. Oh, this is this. Oh, okay, cool.
Yeah, that's just that. So that's what you plug into.
Oh, and you're just saying that like, oh, for this,
Yeah.
there's different branches.
And,
Oh,
yeah,
cool.
Depending on the subscripts you put, it's like a different branch.
Oh, that's fucking cool.
And it just turns
okay.
out that -1 simplifies to.
It turns into pi. Okay, so omega minus 1.
Omega minus
okay.
That
Omega minus
entire
1 of this
can be
thing ends up equaling log of pi over negative pi or something. I see.
Yeah, something like that. Yeah.
Oh. Dang, that's cool. Where the hell do these functions come from, dude? I've never seen these ever in my life. What topic does this like come up in?
I
think it's just,
found it doing the infinite tetration thing. You know,
Okay.
like the
Oh, the x to 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 the x.
yeah, you can rewrite it iteratively, like doing that. And then you can solve for it using Lambert W.
Someone says Lambert was a lonely man. Aw, poor Lambert, dude. Okay, and then this one is this E? What is this 2.38? Is this anything special, or it's just ridiculous?
It's not E.
Damn, I wish it was. It looks close.
Forget what E is. E is
It's just like
2.718.
It's some
Yeah,
random transcendental solution to this equation.
What does
I don't think
transcendental
you
mean
can
again? Does it mean like it crosses multiple continents? What's transcendental?
It's like it's not algebraic, so you can't write it as a root of a polynomial.
So it's not rational at all. It's more than irrational. It's like beyond.
It's like double irrational.
Double irrational, dude. It's got like too many felonies on its count. Okay, cool, nice. Transcendental, not the solution to any polynomial with rational coefficients. Very cool. Poonraj asking what website is that? That's Wolfram Alpha. Yes. Okay, cool. This is a cool question, River. I appreciate this. And then I really appreciate Joseph hopping in and showing me this thing. That's very cool.
Yeah, I'm gonna go back to lurk in chat now.
Okay,
bye.
all good. Thanks, Joseph, for coming by. Cool. Good question too, River, by the way. I thought this was fun. Thank you. I learned something today.
Well, I knew it was a transcendental function. I just didn't know that.
It can't be solved
you couldn't
algebraically.
solve. Yeah.
Okay. That was fucking cool, though. Was it solved? We did solve it. Trolls Cats! Almost done, champ! Thank you, Trolls Cats. I swear, he comes in exactly when I'm like ending my stream to be like, you got this, bro. Thank you, Trolls Cats. And thank you, River, for this question. It was fun. What are the subscripts in the Lambert function mean? I think it means like the root, or like what branch of the root you're looking at.
Lambert W isn't a function of x.
Lambert W is a function of x.
Multiple solutions is not a function of x.
It's not a function of x, sorry.
It folds over itself.
Right. Okay. Different branches. Yeah. Similar to like if you do like, what is it? I don't know, like z to the third is equal to 1, right? You have a bunch of different solutions for that or something, right? They're different branches. It's like e to the pi over 3, 2 pi over 3, 4 pi over 3, 6 pi over 3 or something. Yeah, I think it's where it comes from. I need to get into that stuff. That's more like complex analysis stuff. That's cool. All right, let's see. What else were we doing? Oh, and then let me post your solution in. That was cool. All right, we got 37 minutes left. I think I can get through a lot of these. Let's see. The third root's a unity. Yeah, like the cube root has 3 branches. Yep. Very cool. Ooh, there we go. Someone got a circuit question for us. I love circuits. All right. I have circuits too. My circuits have noises. All right, find VA minus VB. Fascinating. I always like have to like I don't like this. This is ugly. I have to like revisualize things. Well, current in wire BC. Well, yes. If B and C are at the same potential, there wouldn't be any current. My circuits transport blood. Yeah. Well, let's see what the potential is at B and the potential is C. Oh, you're very welcome, River. Thanks for coming by. Thanks always. How did you get so good at maths and physics? Did you study it? Yeah, no, I have a PhD in physics. But even having a PhD in physics doesn't mean necessarily you're good at like teaching or doing all these things in physics. You get good at these things from doing. So I would venture to say I know a lot of PhDs that probably couldn't even do this problem. They can't do circuits, like, because they just never looked at it, never worked with it. A push, yeah, no, A push sucks. We're sorry, dude. I feel like I want to do KVL for this. Yeah, exactly, right. Yeah, this is just ugly. I want to write this in a different way that looks better. It's just very hard to visualize it like this, right? So let's see. So this splits into a 3 ohm branch, right? And I always need to like label these with colors because otherwise I don't fucking see what's happening. So this is gonna be 3 ohms, and it goes here to B. But then I also need it to skip over with 2 ohms to some point C. It's like a wheat stone. I think it's like a wheat stone, right? This is point C. And then B and C connect to each other. Right? And then I need B to go to A via a 2 ohm resistor. So that goes to A. But then C also goes to A. Yes, it's a wheat stone. Well, except that there's no resistance here. Uh-huh. Cool. Did we get it all? C and A, yeah. And then this all goes back to the 12 volts. Okay, why is there current in BC? Well, the only way there wouldn't be current is if the potential here was the same as the potential here. Which they are in parallel. Oh, but this acts like a splitter. Oh, okay. Right. The voltage in the whole leg should be equal to the voltage in the whole leg here, but this splits it at unequal parts. So, if this was 2 and this was 2, then yes, this would be the same. Laplace transforms are tricky, yeah. Okay. Let me remember how we do this, though. I did resistors in parallel. Which resistor did you put in parallel, though? These are in series with each other. Pretty sure. Do parallel resistors and find the voltage in the center. Oh, yes. Okay, now I remember how this works. Yeah, you're right. You guys are super right. Here, yeah, this is very cool. Yeah. So watch. This is how this works. So you have this, which is 3, right? And then this, which is 2, right? But then B and C, like, collapse on each other because it's, like, its own little wire, I guess. And then this is also connected to resistors in parallel of 6 and 2, right? I think this is the way we do it. And then you find the voltage in the middle. Like, the voltage drop here, I guess, compared to this. Okay, so... yeah, not necessarily, because here's what happens, right? So, current always flows wherever it sees an easier path to go down, right? So, looking at the 2 and the 3, you're going to have more current flowing through here than here, right? Now you get to this point, and this current can say, hey, I can go across the 6, which would suck, or I can go up here and then go across the 2, right? It's going to try to, like, put more of it that way. This one, which didn't have as much current, is going to put more this way, but it's still also going to put some this way. So then there's a difference in, like, the current from here that comes up to here versus the current from here that comes down to here. That's why they're not at the same potential. So, this is... yes, but can it go that way? If we assume the cable doesn't have any resistance, shouldn't IBC equal to 0? No, not necessarily. I don't think so. I think there is current. So, what is this? That's right. First, I thought it was a Wheatstone bridge. Yeah, it looked close, right? Let me show it for people who are wondering. We keep saying this Wheatstone bridge thing, right? This is a Wheatstone. And they use them to, like, measure, like, voltages and currents and stuff. And then you have to, like, balance these or something, I think. I forget. 2/6. So what's this? 6/5? So 6/5 is this resistance. And then this resistance is 6/4. Oh, one sec. We're gonna reload this. Okay. So that equals like 1.5 ohms. So then... I think I find the voltage drop here after this. Is this what I do, Femvox? Do I find the voltage drop after this? You could do a voltage divider now. Interesting. You found the current first. Okay. Well, the current, right, is... No, I don't think... You can't take 3 and 2 being in series, being parallel with 2 and 6, because this thing connects them. You can, however, take these two to, like, meet together, and that's how you can say these are in parallel in series with these two in parallel. Right, okay, so then the total current... so 12 volts would equal to I total times 6/5 plus 1.5. Femvox talked to this? That's cool. So, whatever, that's a nasty number. $12 divided by 1.2 plus 1.5. So 4.444. Okay. Okay, so that's the current going through the whole thing, right? Oh, okay, so then you know the voltage drop across each one of these things, right? So I know what the total current is. Got you. Okay, so then V left is 4.44 repeating times 6/5. So that's 5.33. And then we know the other one must be, well, let's make sure it adds up to 12. $6.66. Yep. Cool. All right. So that's the voltage here. Satan's circuit. Interesting. So VA minus VB. Oh, so VA minus VB is the voltage across, the voltage difference across this, which is 6.66 volts, right? Because now we know the voltage across this entire thing is 6.66 volts, but the 2 is in parallel with the 6. All right, so this is 6.66 volts. And then, wait a minute, how do we figure out the current in BC? Because now I connected them. Oh, sorry. Yeah, sorry. I did VB minus VA. Yes, you're right, Fem. Yep, sorry. I did, yeah, negative. Sorry. Yeah, VBA is equal to 6.66, but VAB is equal to negative 6.66. But wait, yeah, if there's zero resistance here, but I think but wait, and this point shrinks onto this point, isn't there the same voltage? So the current should be 0? I was thinking it can't be. They took the difference of the... Oh, okay. Oh. Yes, I know how we're gonna do this. Yeah, let me show you. Let me show you. We're gonna use Kirchhoff's current rules is what we're gonna do here. This is so funny. Oh man, this is kind of a pain in the ass. Okay. So watch. Let me give you some currents. So for instance, I3 right here, right? That's going to equal to V3 over R3, yeah? And then I2 is going to equal to V2 over R2. Will you be the current through my resistor? What is it? We're doing like circuits pickups lines? I remember how this works. It's actually really cool. So V3, that was the voltage in each of these legs that were in parallel. So that's 6/5 divided by 3. And then I2 is this voltage, which was 1.5 divided by 2. And then here's the cool thing. So 6/5 divided by 3, what's that? 6 divided by 5 over 3. So this is equal to 0.4. This is equal to 0.75 amps. Yeah? Now watch. Oh, wait. Yeah, you're right. I did mess this up. My bad. I did this wrong. Making mistakes in the third hour. Fuck. Alright, yeah, sorry. This voltage was 4.44. Wait, no, it's 5.33. Okay. 5.33. Yes. And I'll show you why. And then this is divided by 3. And then this is 6.66 divided by 2. So what? This is equal to like 3.33 repeating. Where's our 5.33? Yeah, these numbers are like horrendous, dude. What? Okay. 1.77 repeating. Half a devil, 3.33. So here's a cool thing. So you have, right, 3.3 repeating amps running this way. But then through resistor 3, you have 1.77. But by Kirchhoff, right, current in has to equal current out. So there has to be another term here, right? In this case, it's going to be the opposite direction, but whatever. I'm going to label this as like IBC, right? So current in has to equal current out. So 1.7 has to equal to IBC plus 3.3 repeating. Move it over. You're going to get the IBC is negative. It means it points the other direction, right? So this minus you're going to get that IBC, and we don't need the Wheatstone anymore, is equal to negative 1.5 repeating. So you can say that this is going to be 1. So the current wise in BC is 1.5 repeating amps, and you can say from C to B. Yeah. And the reason why that makes sense, again, because look, in this circuit, yeah? Let me use this for, okay, so think about it. Current splits. It can go this way, or it can go this way. The current that went this way now has another choice. I can either come up and go through the 2, or I can go through the 6. I don't really want to go through the 6, because that sucks. That's a lot of resistance. So I'm going to really want to come this way and then come through the 2. And then for the current that came through the 3, well, not as much of that came through the 3, right? Because more of it wanted to go through the 2. So when it gets to here, right, some of it is going to try to go to the 6, but most of it's still going to go through the 2. So that's why you get a net current through BC up. Does that make sense there, Drew? I want golden currents. You want golden current C, maybe? Yeah, it's kind of a fun one, right? Circuits are great. I love circuits, actually. I'm a really big fan of circuits. You hate circuits? No. You got it? Nice. Cool. Awesome. Great. I'm glad you got it, Drew. Big shout out. Thanks, JC, and who else was helping me on that one? Femvox. Yes. Thanks, JC and Femvox. Yeah, we've done that one. That's like the second time I've done that question in the last couple of weeks. I'm finally getting the hang of it. Nice. Nice one, Drew. I agree, because my gut intuition at first was like, wait a minute, these wires are connected to each other. There can't be current. And then you have to think about the paths. You got to think about like, oh, well, the current wants to come back up to go through the 2 instead of going through the 6. How's my day? Thank you, man. My day's doing all right. What's it, Sunday? Yeah, we're doing okay. Doing great. All right. Next up, I'm totally not Dom. Who's on not totally not Dom? Someone's giving me Fibonacci questions. Okay. Let C be a given positive integer. C is greater than or equal to 2. Let's f of n be the sequence of Fibonacci numbers. Prove that every integer n is greater than 1. Fc plus n is equal to Fc Fn plus 1. Fc minus 1 Fn. Yeah, I'm gonna skip this right away. You can take the money, Jeff. Just because I only have 14 minutes left, and I have seven questions still to go through. And yeah, maybe I'll get to poisons, but yeah, this is a cool question. I'm gonna put it in our Discord so that it still gets added into the list of questions that could get solved by other people. Mine are easier. Okay, let's go see. Let's see what you got. Well, first I gotta do this. Ooh, okay, here we go. This is a... looks like a GCSE question. My only costs 1 gold and a half. Okay. The gravitational potential between Earth and Moon due to combined effect is... that amount. Oh, cool. Calculate the minimum speed at which a rock would have to leave Earth in order to reach the Moon. Oh, okay. The potential... and warm my warmer? I'm glad. Okay. Increases to a mass of that. A rock, in your calculation, you may assume that the rock has 0 kinetic energy when it has maximum potential energy. Radius, mass of Earth, radius of Earth. Well, you just have to overcome the potential, no, right? Okay. Got Earth. Yes. Yes, no, I appreciate that, Riley. Are you in our Discord, Riley? What's your name in our Discord? This is Earth. I love people who want to help outside of office hours. You guys are the real champions. My government name, is it Riley? So wait, there's a maximum potential here. The gravitational potential increases to a maximum. I feel like you just need kinetic energy to beat out gravitational potential energy, right? But it's weird because there's also like the Earth here. Sorry, there's also the moon. And then we say like, I guess like V max. Or potential mass. Let's say that, phi. I mean, that's what I want to do. I do want to just do the escape velocity formula. But I feel like this does something, because the escape velocity formula does not care about the moon. Poison and Poseidon are anagrams. Yeah. Is he the Poseidon mouse? Was there more information given this one? Yeah, the moon's... Yeah, it should, right? Calculate potential of the surface. Okay, well, I can do that, right? That has to do with... I'm the sexiest mouse. I have a big trident. And we don't have the mass. Okay, well, I know gravitational force, right? That's equal to big G, and then it's M Earth over R squared. But then potential, I think, is this over R, right? Because it's really just like equal to like it's equal to like field over M. Yeah, GM over R. Exactly, right? Yeah. And it's also negative. Okay, sure. Yeah, because usually this would be like M of the rock over R squared. But this looks a lot like electrostatics, right? In electrostatics, Coulomb force is K Q1 Q2 over R squared. But then potential is just equal to KQ over R. That's the inspiration I had for doing this. I'm just like, well, it looks the same. I know when you integrate, that's just what happens. Exactly. Yeah. It's very cool how it is like that. Yeah. Okay. And then what's the constant for G? 6.67, I think, times 10 to the minus 11. Or we'll just leave it as G for now. Right? Okay. So then 1/2 mv squared plus negative gm over r Earth, right? And then we want to figure out where like the... Exactly, yeah. 6.67.
Surprise, motherfucker.
Oh, no, dude. Not again. Fuck. Okay. Right. And that has to be equal to, hopefully when this has, like, 0 speed, and then just has potential, right? Because I assume once it gets to here, then it'll start becoming attracted to the moon. It's like, after enough, you know, dinner dates, finally the moon's like, yeah, you can come back. I'm attracted to you now. Oh, fuck. Okay, cool. All right. I think this is it. I think this is the setup, right? This is energy at surface. Right, because this is plus 1/2 m v squared, but this is 0. Would that be a Lagrange point? Maybe. This is energy. The negative potential thing just is like weird sometimes. Okay. Oh, wait. But this is per kilogram. So this is times m. This is m of the rock. Fascinating. Would it not be 1/2 v squared because it's in the units of... Yes. Yes, I think this goes away as well. You're right. Yeah, and sorry, I don't think there's an m here either. Right, because otherwise I would need an m here, I would need an m here, and I would need an m here in order for this to work. But this is 1.28 kilograms, sorry, megajoules per kilogram. So I think actually potential... Right, does not depend on the mass, but then... Oh, okay, the potential energy is the potential times the mass. Okay, that's what it is. I figured it out, Okay, in the same way, right, that potential energy, like energy, electric, whatever, fuck, potential, this is equal to QV, where this is kind of like the mass times the potential. I got you. So, this is the potential, but the potential times the mass is the potential energy. This is the kinetic energy, and then this needs to be also multiplied by m, but all the m's cancel. Okay. I think I got it. Okay. So this is equal to 1.28 times 10 to the 6 plus 6.67 times 10 to the minus 11 times... Yeah, 6... Troll cats, we're almost there. 5.97 times 10 to the 24. Right. Good. And then over the radius of the Earth, 6370 times 10 to the 3. And then we multiply all of that by 2. And then we take a square root of it. It's there. It happened, dude. The 6-7 happened. Okay. All right. I'll get an answer for this. One sec. I'm nice. We did lose a negative sign. Thank you, Fem.
Good job.
Yeah, I fucked up. There's a minus sign here. This one did become a plus, though. Yeah, you're right. Dude, this is why I hate space stuff. It's all the fucking exponents. Like, I don't want to deal with this. Okay, all that times 2 to the 0.5. So we get 10,000 meters per second. Jesus. That seems high. That's very fast. The fuck's traveling at 10,000 meters per second? Really? That's really fast. What's that in miles per hour? Oh, Earth's escape velocity is 11 kilometers per second? Oh, cool. Okay, so you just have to be going, I just Googled this. 24,800 miles per hour. Wow. That's really fast. So yeah, cool thing here. I think that this term really didn't do much. Just giving a hint, giving a hunch there. And the reason for that is you have like 10 to the minus 11, 10 to the 24. That's 10 to the 13 already. Sure, divide by 10 to the 6. You're at 10 to the 10, but 10 to the 6 isn't going to do shit. Anyways, yeah, cool question. Thanks, Darkeezy. That was PQR dy. Thank you, Olaf. Bless you, Olaf. Yeah. Very, very fast. Let's see. What do we got next? I got 2 minutes left. 2 minutes. What can we do in 2 minutes? What?
Surprise, motherfucker.
Phasey, what the fuck is this? Dude, this is... He says I know this one. This problem is cute. Is it cute? I think I need this to equal 1. I need this to equal 1. Right? X to the 0 equals 1 and 1 to the x equals 1. Oh, the exponent can equal 0. Ooh, okay. Okay, yeah, this one's not too bad, right? Because I can factor this, right? X squared minus 11x plus 30 is the same thing as x minus 6, x minus 5. Right? So I have x squared minus 7x plus 11 to the x minus 6, x minus 5 is equal to 1. Okay, what is this? Oh, sorry. X to the 0 equals 1. This is another like this. Yeah, this is kind of fun stuff. Yeah. And then yeah, you have to make sure you're not doing 0 to the 0, right? Right. The other case where -1 is raised to an odd number. Oh. Because as long as this isn't 0, right? And yeah, this, what are the factors of this? 11 doesn't have any nice factors. But I could say x squared minus 7x plus 11 is equal to 1, right? So that's x squared minus 7x plus 10 is equal to 0. And now this is x minus 2, x minus 5. Okay. Wait, what's the eccentricity? Sorry, JC, what are you saying here? -1 to the, oh, to the even. Okay. Okay, so you can do x squared minus 7x plus 11 is equal to -1. So that's x squared minus 7x plus 12 is equal to 0. So that's x minus 2. Wait, no. X minus 3, x minus 4. But then you need this to be even, right? 3 minus 6 times 3 minus 5. -3 times -2. Oh, so that works. So x equals 3 works. And then, does 4 work as well? 4 minus -2 times -2. Yeah, also works. Oh, okay, so x equals 3. X equals 4. These work. That's cool. Yeah, that's -1 to an even number. This is just 1. This is 1 to the blah. And then this is blah, blah, blah to the 0. So is it 3, 4, 5, 6? And then does 2 work? Yeah, 2 should work, right? Yeah. And then 2. So wait. 2, 3, 4, 5, 6? Nice! Wow! That's actually really cool. Thanks, Phasey. That's actually a really fun question. Yes, Chad agrees. That's a fun question. Chat agrees. That's a fun question, Fazy. Thanks, dude. Good one to end us off on. Yeah, sir. I'm over time. I gotta close out the stream. So let's go. All right. Thank you, everyone, for coming to Actual Education Office Hours today. Really appreciate the questions. Oh, Poison. I know you were right up next. Yes, I know. But I do have to go. I'm over time. I have to go teach someone else. Good night, Ryan Gosling. All right. Yes. So don't worry if we didn't get to your question today, because I know we had a lot of questions. So Poison, yeah, look at all. Well, Poison, there's a lot going on here, dog. What? This is not exactly just easy stuff to go through. What? The resistance of a cone. Poisoned. Kepler equation. That's a fun. Ooh, a Laplace transform. That's another fun one that we could have done. Blake. Ooh, with a series question. I feel like this is an arithmetic series. No. Okay. Anyways, not to worry. If we didn't get to your question today, because it was there, it will still get put into our Discord. So make sure you go to this website, actualofficehours.com. Join our Discord. The question will get put into our channel. It's called Homework Help. And there I have another awesome group of friends, streamers, partners, friends, amazing people who also like to just solve these problems on their spare time. They're very generous with their time. And they may do it in the off period that I'm not streaming. Otherwise, if you click here on streaming schedule, there are other people who stream, such as Zach.
Bing bong. Good job.
And Penn Center. And Joseph will post his schedule here at some point, but this is where you can figure out the next time that we're streaming and the next time any of our other friends are streaming. If you want to ask them math or science questions, especially the Laplace question, Zach, E2IPi, just did 2 weeks of lectures, or two back-to-back weeks, where his math education on a topic thing I think was Laplace transforms. So. Very cool. Yeah, no, I'm glad. Yeah, if you found us, awesome. Make sure to go follow us on Twitch, YouTube. All the recordings are posted onto YouTube. Twitch is the better format for horizontal. So if you're on a desktop or a laptop, make sure to watch it on Twitch because it looks a lot nicer. I have to do vertical for YouTube and TikTok because that's just the only way we get discovered. And then Joseph's going to teach you chem. Hell yeah. Yeah, and again, so if you need help, we'll be on tomorrow. At 3 o'clock Pacific, 4 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. So come on by then and get more help. So if you're watching us on Twitch, which I highly recommend you follow us on Twitch, we're going to go raid another friend who's streaming. So let's see, who's on? Someone's doing some co-working. Science is starting soon. Nerduino. Is Nerduino up? Yeah, let's go say hi to Nerduino. Or Moo Hoodles is up right now. Yeah, Moo Hoodles is streaming right now. Okay, we're going to go say hi to Moo. She's great. I met her at TwitchCon. But yes, if you're on Twitch, stand on by. Go say hi to Moo. She's a great astronomy streamer as well. All right. That being said, enjoy the rest of your weekend. We will see you guys tomorrow. Peace.